It's time to experience something glorious. Unacademy Combat. Compete, crack, conquer.
A challenging gate contest engineered to give you an experience like none other.
Where you put your knowledge to test
and battle it out with a test
To bring out the best in you, Unacademy Combat is the most competitive, gamified contest for gate till date, with the best of the questions by best educators.
with detailed video solutions from top educators right after each contest.
Combat live with peers to get real-time rankings and win big.
Participate in every contest to improve your ratings.
Challenging contests every fortnight or alternate Sunday. Live ranking after every question. Big rewards for top rankers. Your passion to crack gate deserves this. Your hard work towards your dream deserves this. Fuel your inner fire for the ultimate gate challenge. Unacademy Combat. Register now.
गुड मॉर्निंग टू ऑल माय डियर फ्रेंड्स, वेलकम टू अनअकैडमी। कैसे हो मेरे प्यारे दोस्तों? आई होप दी ऑडियो एंड वीडियो आर क्लियर। ओके, वेलकम टू दी 7th सेशन ऑन आरसीसी। इट्स ए क्रैश कोर्स डियर और इसको लीड कर रहा हूँ मैं, आपका दोस्त ऐश्वर्य, जो कि टीएससी का एजुकेटर है। एंड आई हैव कंप्लीटेड माय मास्टर्स फ्रॉम आईआईटी दिल्ली एंड बीटेक फ्रॉम जामिया कॉलेज। 4 times I have qualified GATE with my best AIR 226 and I do have 7 years of teaching experience and 2 years of industrial experience. Dear, मैं cover करता हूँ आपके more than 50% of the subjects in civil engineering and this is our official telegram channel जिसको आप join कर सकते हो for the latest notes and notification. Okay, and we do have lot many free content available on Unacademy Learning App as well as on Unacademy official YouTube channel, but still I recommend my learners to go for Plus and Iconic plan. The reason being, Plus में हम लोग आपको देते हैं डेली लाइव क्लासेस, वीकली टेस्ट, स्ट्रक्चर्ड मैनर में कोर्सेज, क्रैश कोर्सेज, रैंक इंप्रूवमेंट बैचेस एंड अनलिमिटेड एक्सेस टू द कंटेंट। अगर मैं बात करूं आइकॉनिक की, जो कि सुपर सेट है प्लस का, जिसमें आपको प्लस के सारे बेनिफिट के साथ साथ प्रोवाइड कराया जाता है एक पर्सन कोच जो आपकी स्टडी की प्लानिंग, स्टडी बूस्टर सेशन, पर्सनलाइज्ड टेस्ट एनालिसिस, इन सब का ख्याल रखते हैं। स्पेशलाइज्ड नोट्स एंड प्रैक्टिस सेट्स भी आपको प्रोवाइड करवाते हैं along with the dedicated doubt clearing educator. So whether it is a matter of plus or iconic, so feel free to use this code AISH10 here. एंड कॉम्बैट जो आपका रहेगा दैट इज एट इट्स ऑन टाइम 11 AM पे होता है और नेक्स्ट संडे इज ऑन 9th of Jan, so you can enroll yourself for combat by using this code AISH10. It is the India's largest weekly competition plus come scholarship test for GATE where you guys are able to access your preparation in less than 60 minutes. चैलेंजिंग और ओरिजिनल क्वेश्चन यहाँ पे मिलते हैं विच आर क्रिएटेड बाय बेस्ट एजुकेटर एंड यू गाइस कैन क्रैक विद कॉम्बैट. सो नेक्स्ट कॉम्बैट इज गोइंग टू बी लाइव ऑन 9th Jan एंड 11 AM एंड इस बार 100 लकी पार्टिसिपेंट्स कैन विन rewards like Apple iPad, JBL headphones, Samsung tab, speakers, Amazon vouchers, etc. Not only this, अच्छा ये मैं आपको बता रहा हूँ कि प्लस और आइकॉनिक सब्सक्रिप्शन के प्राइजेज ये हैं आपके पास, बट ये प्राइजेज आज के लिए नहीं है क्योंकि आज आपके लिए है ऑफर का लास्ट डे. अगर आज आप अपना सब्सक्रिप्शन प्लान करते हो बाय यूजिंग AISH10 तो आपको मिलता है 22% डिस्काउंट इंस्टेड ऑफ 10% डिस्काउंट. आपको कितना मिलेगा? 22% मिलेगा, बट ये 22% आपको मिलेगा सिर्फ आज रात मिडनाइट तक. Okay, so if you are planning your subscription today, then you can avail extra 12% discount, and you can see here you can get 22% off on your any Unacademy subscription. गेट ESC में तो वैलिड है ही, और आप कोई भी ब्रांच में अगर आप सब्सक्रिप्शन लेते हो then 22% off will be there. And this is the AIMT All India Mock Test. ये भी हो रहा है आपका 2 जनवरी से 30 जनवरी के बीच में. एक टेस्ट ऑलरेडी वी हैव सक्सेसफुली कंडक्टेड विच इज CBD मॉडल, एंड नेक्स्ट टेस्ट इज अगेन देयर ऑन 9th of Jan morning 9 AM. Again the questions are created by top educators. You can cover the entire syllabus here. You can experience the actual exam like setting. You will be getting all India ranking and you will be able to identify the areas of improvement with the detailed analysis and video solutions by top educator. So enroll now by using the code AISH10. नए बैचेस आप देख सकते हो कि आज ही स्टार्ट हुए हैं नए बैचेस. आज सिविल में फर्स्ट बैच स्टार्ट हुआ है फॉर गेट 2023 अंडर इवॉल्व सीरीज, एंड यू कैन सी कि नए बैचेस नॉट ओनली इन सिविल बट आल्सो दे आर started in mechanical, electrical, EC, CS, IT, chemical as well. तो चलिए 7वां लेक्चर है क्रैश कोर्स का और टॉपिक है एनालिसिस एंड डिजाइन ऑफ डबली रीइंफोर्स्ड बीम. तो लिमिट स्टेट मेथड हम लोग पढ़ रहे हैं. लिमिट स्टेट मेथड में हम लोग सिंगली रीइंफोर्स्ड बीम कवर कर चुके हैं, और उससे पहले हमने लिमिट स्टेट मेथड का कुछ बेसिक इंट्रोडक्शन भी देखा, assumptions देखे, स्ट्रेस ब्लॉक को समझा, लीवर आर्म निकालना सीखा, मोमेंट ऑफ रेजिस्टेंस निकालना सीखा, फिर उसकी एप्लीकेशन और डिजाइन हमने किया अपने प्रीवियस लेक्चर में. कल का लेक्चर जो था उसमें उसका एनालिसिस और डिजाइन हम लोगों ने कवर किया, और आज हमारा मुद्दा है डबली रीइंफोर्स्ड बीम. डबली रीइंफोर्स्ड बीम में आपको याद दे रहा हूं, हमने वर्किंग स्ट्रेस मेथड से मैंने आपको नहीं कराया, इंटेंशनली नहीं कराया बिकॉज इट इज नॉट वेरी मच रिक्वायर्ड फ्रॉम गेट पॉइंट ऑफ व्यू, although such topic are required for your ESC conventional exam. ESC convention के लिए वो टॉपिक रिक्वायर्ड है, बट गेट के पर्सपेक्टिव से दैट इज नॉट इम्पोर्टेंट. बट यस LSM इज वेरी इंपॉर्टेंट टॉपिक फ्रॉम गेट ऑफ पॉइंट ऑफ व्यू. तो LSM के अंदर हम कोई भी टॉपिक के साथ रिस्क नहीं ले सकते, इसलिए ऑल द टॉपिक्स ऑफ ऑन LSM विल बी कवर्ड इन अ डिटेल्ड मैनर अंडर द क्रैश कोर्स ऑन RCC. ओके, तो स्टार्ट करें. स्टार्ट करने से पहले डियर एक बार सेशन को शेयर कर दीजिए. प्लीज शेयर द सेशन, डियर ऑल ऑफ यू. मैं अभी एक बार कर देता हूं. ओके, तो एक बार सेशन शेयर कर देंगे सब लोग और फिर करते हैं हम लोग स्टार्ट. ओके तो मैंने कर दिया है शेयर सेशन को, आप लोग भी कर दीजिए अपने अपने ग्रुप में और देखते हैं कितने लोग ज्वाइन करवाते हो आप लोग। ठीक, तो चलो स्टार्ट करते हैं। एज आई प्रोमिस्ड यू, थिंग्स विल बी कवर्ड इन शॉर्ट स्पैन ऑफ टाइम बिकॉज आई विल बी यूजिंग प्रेजेंटेशंस एंड ऑल, और हर एक सेशन में अलोंग विद द यू कैन से थ्योरी न्यूमेरिकल्स वुड आल्सो बी देयर। तो न्यूमेरिकल सेशन अभी हमने बस कल के सेशन में नहीं रखा, उसके पीछे भी लॉजिक है क्योंकि आज का सेशन न्यूमेरिकल कल के सेशन के कंसेप्ट्स को भी करेगा कवर। ओके तो अब स्टार्ट करते हैं डियर। नेक्स्ट, तो here are we on syllabus, we have covered this and right now we are covering, we are here। ओके तो आज और कल का लेक्चर फ्लेक्सर खत्म कर देगा, फिर परसों से हम लोग स्टार्ट करेंगे शियर एंड फिर टॉर्जन फिर बॉन्ड एंड ऑल। ओके चलिए, तो स्लैब और कॉलम में एज आई टोल्ड यू अर्लियर ओनली कि आई विल नॉट बी डिवोटिंग मच ऑफ द टाइम। ठीक है, एक एक लेक्चर में इन दोनों को खत्म करेंगे एंड देन वी विल बी गिविंग मेजॉरिटी ऑफ द टाइम टू प्री स्ट्रेस कंक्रीट। तो स्टार्ट करते हैं। तो इन फर्स्ट फेज, तीन फेज में आज का लेक्चर है। पहले फेज में हम लोग करने वाले हैं एनालिसिस, दूसरे फेज में करेंगे हम लोग डिजाइन डब्ली का ऑब्वियसली, और तीसरे फेज में हम डिस्कस करेंगे एक आधा अच्छा न्यूमेरिकल जिससे सारे के सारे कंसेप्ट्स पढ़ाई वाली चीजें हमारी रिवाइज हो जाए। ओके तो लेट्स स्टार्ट विद फेज 1 व्हिच इज एनालिसिस ऑफ डबली रीइंफोर्स्ड सेक्शन। एनालिसिस डियर वैसे ही होगा जैसे सिंगली का कराया जाता है। जैसे सिंगली में मैंने आपको एनालिसिस कराते वक्त बताया होगा कि देयर आर 4 स्टेप्स। ओके, पहले लिमिटिंग डेप्थ निकालना, फिर एक्चुअल डेप्थ निकालना, देन वी डू हैव टू डू कंपैरिजन, आफ्टर दैट वी हैव टू कैलकुलेट मोमेंट ऑफ रेजिस्टेंस। मोमेंट ऑफ रेजिस्टेंस आने के बाद यू कैन आल्सो कैलकुलेट द अल्टीमेट लोड एज वेल एज सेफ वर्किंग लोड। ओके सो सेम 4 स्टेप में यहाँ पर भी आपका एनालिसिस कंडक्ट किया जाएगा। बस डिफरेंस अब ये आने वाला है कि पहले हम लोग कंप्रेसिव फोर्स और टेंसाइल फोर्स को जब हम रिलेट करते थे, इक्वेट करते थे, तो पहले कंप्रेसिव साइड में ओनली कंक्रीट वाज पार्टिसिपेटिंग एंड टेंसाइल साइड में ओनली स्टील वाज पार्टिसिपेटिंग। बट नाउ द डिफरेंस इज कि डबली रीइंफोर्स्ड बीम का एनालिसिस और डिजाइन करते वक्त कंप्रेसिव साइड में वी विल बी हैविंग कंक्रीट प्लस compressive steel. So now these two forces due to these two component, concrete as well as compressive steel, is going to be equate with the force of steel here. Okay, tensile reinforcement. Accordingly, we will have to calculate actual depth of neutral axis. No difference would be there in calculating the ultimate depth of neutral axis. Comparison, no difference. But yes, again, when moment of resistance we have to calculate, and again we have to calculate moment of resistance due to both the components, means concrete component as well as a compressive steel component. Okay, so पहला स्टेप है हमारे पास कैलकुलेशन ऑफ एक्सियल लिम। एज आई टोल्ड यू देयर इज नो डिफरेंस, कोई भी डिफरेंस नहीं है क्योंकि एक्सियल लिम को सिर्फ और सिर्फ मतलब है ओनली ग्रेड ऑफ स्टील से। ठीक है, क्या करते हैं हम लोग, दिस इज एक्सियल लिम और हम स्ट्रेन डायग्राम बनाएंगे एट द टाइम ऑफ कोलैप्स and at the level of most compressed you can say is this let me check one thing. ये ऐसा क्यों आ रहा है यार, चलिए कोई नहीं, some issues there. Okay, स्क्रीन का इशू है क्या, पीपीटी में इशू, चलो कोई नहीं। तो एक्सियल कैलकुलेट करते वक्त वी हैव टू डिपेंड ऑन ग्रेड ऑफ स्टील ओनली। ओके, एंड सेम रूल लाइक फॉर Fe250 वी कैन से if I am substituting 250 here you would be getting 0.53D, 415 के लिए 0.48 d and 500 के लिए 0.46 d. Okay, so no difference in step number 1, so I can call it step number 1. Next step, calculation of actual depth of total axis. This is step number 2 and it is actual depth of neutral axis. This is actual depth of neutral axis. This is different. यहाँ क्या करने वाले हैं अपन लोग? हम लोग कंप्रेसिव फोर्स को टेंसाइल फोर्स से इक्वेट करने वाले हैं. As you can understand, this is your area of steel. This is also area of steel. In fact, this is area of steel in compression. So ASC कुछ कंपैटिबिलिटी इशू आ रहा है, शायद कुछ कंपैटिबिलिटी इशू आ रहा है, पता नहीं पीपीटी एक्सपोर्ट में कोई दिक्कत हुई है, क्या हुआ है. ठीक है, तो ये हमारे पास है कंप्रेसिव रीइंफोर्समेंट और ये है हमारे पास टेंसाइल रीइंफोर्समेंट. तो दिस इज एक्सयू अप टू हियर, दिस इज एक्सयू, एक्चुअल डेप्थ ऑफ न्यूट्रल एक्सिस, एंड यू कैन सी दिस इज आवर पैराबोलिक प्लस रेक्टेंगुलर स्ट्रेस ब्लॉक. नाउ व्हाट वी हैव टू डू इन फर्स्ट स्टेज, आई विल बी अज्यूमिंग कि मेरे कंप्रेशन जोन में सिर्फ और सिर्फ कंक्रीट है. अगर सिर्फ और सिर्फ कंक्रीट को मैं तवज्जो दूं तो आपको पता है कि कंप्रेसिव फोर्सेस आर 0.36 FCK B into XU is the compressive forces. 0.36 FCK is average stress and B into XU is area. So average stress into area is the force, compressive resistance by this concrete segment. But my dear friend, there is also steel, and steel is present at the level of this stress value. So there is some portion of concrete which is missing. तो जो मिसिंग वाला कंक्रीट है उसको कंपनसेट करने के लिए व्हाट वी हैव टू डू, वी हैव टू मल्टीप्लाई दिस स्ट्रेस विद दिस एरिया. सो व्हाट इज द एरिया ऑफ कंक्रीट व्हिच इज मिसिंग? इट इज ASC. व्हाट इज द स्ट्रेस एट दिस लेवल? इट इज 0.45 FCK. Okay, so now this is the resultant compressive stress due to the presence of concrete. Here I have considered concrete at all the compressive zone, and whatever the component I have taken in excess, after that I am going to reduce it or deduct it. After that there is also presence of concrete steel here. तो steel को compensate करने के लिए what we have to do? Plus steel का stress which is FSC into steel का area which is ASC. So this is the net compressive force. This is the net compressive force, and this is the net compressive force. और अगर मैं net tensile force की बात करूं, then this net tensile force is equal to 0.87 Fy stress in the steel into area of the steel in tension zone. Okay, so if you are going to equate this CF is equal to TF, then you would be getting your actual depth of neutral axis. You would be getting your actual depth of neutral axis. So you can say that this is one component जो हमेशा की तरह पहले की तरह लग रहा है. तो ये अगर मैं आपसे पूछूं कि कितना लग रहा है, then you all can tell कि this is 0.36 FCK BXU and it might be acting at a distance of 0.42 XU from top. It is acting at a distance of 0.42 XU. और अगर मैं इस की बात करूं, here the line of action of FSC into ASC plus 0.45 FCK into ASC is here. ये आपका लाइन ऑफ एक्शन है और ये आपका लाइन ऑफ एक्शन होगा यहाँ से कितनी दूरी पे? It will be there at a distance of D dash. It would be there at a distance of D dash. Okay, so like that we can do. So the actual depth of neutral axis can now be written as it is 0.36 FCK B into XU plus due to steel minus due to concrete which was absent there, and stress in that concrete is 0.45 FCK. Yes, one hidden assumption is there. Hidden assumption ये है कि जो भी मेरा compressive reinforcement होगा that is lying in rectangular stress block dear. That is always lying in the rectangular stress block. Then only I will be able to write 0.45 FCK. And otherwise my analysis would be more complicated. It would be more complicated. Okay, so 0.45 FCK I have to take. This is equal to 0.87 Fy into AST. Okay, 0.87 Fy into AST. Clear है? Okay, चलो. So this is the case. So this is the calculation of actual depth of neutral axis. Step number 3 is same. Step number 3 is the comparison. Okay, and comparison के there can be 3 cases. Comparison के there can be 3 cases. What? First, when actual depth of neutral axis is less than limiting depth of neutral axis. In such case, the section is called under reinforced section. Okay. Second, when actual depth of neutral axis is equal to limiting depth of neutral axis, in such case section is called limiting section. And case number 3, when actual depth of neutral axis is greater than limiting depth of neutral axis, and such a section is called over reinforced section. So let me explain these cases one by one. Case number 1, you can see limiting depth of neutral axis is here. ये लाल वाला जो मैंने बनाया है, it is the limiting depth of neutral axis. It is not the actual one, it is the hypothetical one, and it is from the assumption that the strain at the level of most compressed fiber and at the level of tensile reinforcement are their maximum permissible value, not maximum permissible value. In fact, आप कह सकते हो कि 0.0035 आपके concrete compression fiber में हुआ है और 0.0020 plus 0.87 Fy upon ES आपके स्टील के लेवल पे हुआ है. तो ये आपका स्ट्रेन डायग्राम है. बट इफ योर सेक्शन इज अंडर रिइंफोर्स्ड, मतलब आपका एक्सियो अगर आपका एक्सियल लिमिट से कम है, तो आप देख सकते हो कि द स्ट्रेन डेवलप्ड एट द लेवल ऑफ टेंसाइल रिइंफोर्समेंट इज ग्रेटर देन दिस वैल्यू डियर. If strain is greater than this, it means steel is going to fail first, because at the time of failure, if assumption number 6 says steel will not going to fail if the strain value is less than this. It can only fail if it is greater than this. Okay, so in under reinforced section you can see steel is in less amount, so that is the reason why the developed value of strain in steel is more than this 0.0020 plus 0.87 Fy over ES. Okay, और under reinforced का अगर neutral axis ये है, then the parabolic plus rectangular will start from here only. So here you can see this portion is 4 by 7 and this portion is your 3 by 7. Okay, so this is what? This is 3 by 7 of axial. This is what? This is 4 by 7 of axial. Okay, and this is the under reinforced case. Okay, क्योंकि स्टील जो है यहाँ पे फेल पहले होगा और ये आपका माइनॉरिटी में है. सेकेंड कंपैरिजन वी कैन से, ये आपका कंप्रेसिव स्टील है. सेकेंड केस जब दोनों की दोनों वैल्यू बराबर है, मतलब नीली और लाल रेखा दोनों की दोनों सेम है. सो इफ ब्लू एंड रेड आर ऑन सेम लेवल, देन डजंट मैटर कि आपका स्ट्रेन वैल्यू यहाँ है. ठीक है, स्ट्रेन वैल्यू और एक्चुअल वैल्यूज आर सेम. सो हियर वी हैव अचीव दिस बैलेंस्ड केस, and here you can see that stresses are going to be originated from actual, or you can say limiting depth of neutral axis. Okay, so from here we can calculate this, और ये मेरे पास आ रहा है यहाँ पे 0.45 FCK 0.87 Fy. So this is the case. Third case आपका when axial is going to exceed axial limb. If axial is going to exceed axial limb, and you know that strain at the time of collapse cannot be less than this. It cannot be less than this. So we have to restrict our depth of neutral axis to limiting depth of neutral axis, because if XU is going to be greater than XU lim, then you can say strain at the level of tensile reinforcement is going to be less than this value, and at this condition failure is not possible. Okay, assumption number 6 says of LSM failure is not possible. So for failure, the maximum permissible stresses in steel, strain in steel should be at least this value. It cannot be less than this. It can be greater than this, that is allowed in under reinforced section, but it cannot be greater than this. Are you getting this point or not? Tell me. So this is the case, dear. This is the case for over reinforced section in our RCC beam. And what else we can do from this side? What else we can do from this side? We can also see that our stress diagram is also formed here. This is parabolic, this is rectangular. This is parabolic and this is rectangular. Here you can see that stresses would be there again due to the presence of concrete, due to the presence of steel, as well as due to the absence of concrete in that steel portion. So due to all these three factors, my forces would be there. Just I have explained to you in case number 2. Just I have explained you in case number 2. Okay dear, chaliye. Okay, next is step number 4, the final step in the analysis, and it says the calculation of moment of resistance. It says the calculation of moment of resistance. So how the moment of resistance can be calculated? This is very easy to understand. Since we have bifurcated our compressive forces into two zones, one due to steel concrete and another one due to presence of steel as well as due to the absence of concrete in the steel zone. So there are two different segments. Their line of actions are different. So the line of action for this concrete segment is 0.42 XU from top. So if you are going to calculate this lever arm, then this lever arm is D minus 0.42 XU. Similarly, if I am talking about the line of action of this steel as well as absence of concrete segment, so here you can see it is located at a distance of DC from top fiber. So lever arm here is going to be D minus DC. So moment of resistance here MU is 0.36 FCK BXU into D minus 0.4 XU plus FSC minus 0.45 FCK into ASC into D minus DC. Okay, and similarly moment of resistance, if you want to calculate from the tensile side, then it is 0.87 Fy AST into D minus Y dash. What is Y dash? Y dash you guys can calculate. Y dash is nothing but the effective depth of line of action of this combined forces. Suppose in place of these two forces, if I would have applied a single force, like थोड़ा सा इसको explain कर देता हूँ. जैसे मेरे पास ये है. Okay, so if this is there, so मान लीजिए कि इन दोनों का जो रिजल्टेंट है वो यहीं कहीं लाई कर रहा है. Let's suppose it is somewhere here. Okay, and let's suppose this is located at a distance of y bar. Let's suppose this is located at a distance y bar, yeah, y dash from the top of the fiber. Then what about the lever arm? Lever arm you can calculate. Lever arm is going to be how much? The lever arm is going to be D minus y dash. Now how you are going to calculate y dash? That is important. So y dash is this force 0.36 FCK B into XU, and its CG from top is how much? It is 0.42 XU plus second force is FSC minus 0.45 FCK into ASC. Its line of action from top is DC divided by total force. Total force is plus 0.4 plus FSC minus FSC minus 0.45 FCK into ASC, or you can say force due to concrete into its into its line of action plus force due to steel minus force due to absence of concrete into its lever arm line of action divided by total net compressive force, or you can also keep it to tensile force. So by this you can calculate the y bar value. Also you can write here y dash is equal to numerator is same, you can write compressive force, or y dash can also be numerator upon tensile force, because compressive force and tensile force are ditto same. Okay, so these are the different ways to calculate the value of y bar, but still I will recommend my learners do not go for tensile side, do not give much importance to tensile side, because we do have a restriction. As I told you in singly reinforced beam, whenever there is a case of over reinforced section, still you have to adopt this side formulation. It's not like you cannot adopt this, you can adopt this, but for in case of over reinforced section, पहले आपको वो area of steel निकालना पड़ेगा जो actually में utilize हो रहा है as per the present scenario of compressive force. So there the work is dual. So just to save time, we can use always compressive side formulations for calculating moment of resistance. And if it is an under reinforced section, keep XU as XU. If it is a limiting section, then simply replace XU as XU lim. If it is a case of over reinforced section, then also you can replace XU with XU lim, and you will be getting your correct values of moment of resistance. So this is the beauty of compressive side moment of resistance formulation. I think you are getting this point. So this is our step number 4. This is our step number 4 here. Okay. Now after that, as I told you yesterday, that design and analysis both are inverse to each other. So here as well, when it comes to design, so we can understand that design is nothing but the part of analysis, or analysis is nothing but the portion of design. So in design, our output is going to be safe load or maximum safe load. Sorry, our output is going to be cross section values, area of cross section as well as area of steel. But in doubly reinforced section, the cross section of the beam is given to you. So you have to design area of steel for tension zone as well as area of steel in compression zone. Okay. And input would be grade of concrete, grade of steel, okay, load, length, support condition, and if these three things are not given to you, then directly they will be giving you bending moment. Okay, but yes, do not forget to multiply load or bending moment with the appropriate factor of safety of load. For dead load and live load, we have to increase our load or bending moment by 50%, by 1.5 times. Okay, so it is a design of doubly reinforced beam, AST and ASC is given to you. So this is the development of a design formula. See how we can develop our design formula. This is our main beam, which need to be designed, and I am going to divide this case into two portions. Now listen to me very carefully here. I am going to divide this case into two portions. First portion is just like your singly reinforced beam. Okay, but this need to be set as for axial limb value. So this entire cross section is divided into two parts. First is singly reinforced beam with its ultimate value, and another is doubly beam, you can say doubly beam for excess bending moment. As you know that singly reinforced beam is also going to have its moment of resistance. Each and every dimension of singly reinforced beam is going to have some maximum amount of moment which it can take safely for some particular for some balanced amount of steel. For example, let's suppose this B and this D can take moment up to 110 kilonewton meter. but you need to design it for 150 kilonewton meter. Then what will happen? For 110 kilonewton, we are going to design this steel. It is known as AST portion number 1. And for axis 40 kilonewton meter, my dear friends, I have to design AST second as well as ASC. Now the resultant uh, you can say now the resultant area of steel in tension zone would be AST1 plus AST2, and the resultant area of steel is ASC only. So but this ASC is being provided for the excess amount of bending moment which could not have been taken by singly reinforced beam of that size. Okay, isn't it? And just you can say for this 40 you are providing AST2, and just to balance this AST2 we are applying some ASC, so like that you can understand. So these ASC and AST2 are being provided in such a manner that it is not going to deviate, or its neutral axis is not going to deviate from the limiting value. So as I told you in singly reinforced section as well, that here we are going to target the axial limb. So whenever we are doing design, we will be targeting our limiting depth of neutral axis, because that is the most ideal. Are you getting this point or not? So this is the case. Okay, so this is the case. ठीक है, चलो. So अब थोड़ा सा इसको फॉर्मुलेशन देख लेते हैं कि फॉर्मुलेशन कैसे कैसे होने वाली है. अब देखते हैं जरा. मान लीजिए आपको बचाना है दिस वन, और ये ले सकता है MU लिमिट, और ये लेगा फिर कितना, let's say M2. And what is M2? It is factor bending moment, axis bending moment minus what? MU limit. Okay, so when it comes to MU limit, so you know what to do. You know that there would be some compressive forces, you know there would be some tensile forces. Okay, you know the lever arm between them. The lever arm is going to be D minus 0.42 of XU limb. Okay, it is D minus 0.42 of XU limb, and for this one the lever arm is going to be different, and here the lever arm is going to be D minus DC. As discussed earlier, lever arm is going to be D minus DC, because this is located at a distance of DC from the top fiber. D minus DC, D minus DC. Okay. Okay. So here what is given to you? This is MU limb, and MU limb is equal to 0.87 Fy into AST into D minus 0.42 times of XU limb. So if you want to calculate AST 1, it is 1, because it is not balancing the entire factor bending moment. It is going to balance only a portion of factor bending moment. Okay, so this is MU limb, or in some textbook, reference book, it is written as M1, but both meaning are same, upon 0.87 Fy into D common look to 1 minus 0.42 K JD. So this is a procedure to calculate AST1. Now my dear friend, whatever is the excess amount, for that ये जो excess amount है, इसके लिए हम लोग क्या कर सकते हैं? This is the excess amount. So here you know that M2 is equal to, this is you know what? This is also you know it is what? It is 0.87 Fy into remaining portion of steel. And just to compensate this, here we have to use FSC minus 0.45 FCK into ASC. So M2 can be written as this, FSC minus 0.45 FCK into ASC into D minus DC, and it can also be written like this, it is 0.87 Fy AST2 into D minus DC. So from here you can calculate AST2, it is M2 over 0.87 Fy into D minus DC. From here as well you can calculate ASC, it is M2 over FSC minus 0. Okay, so this is the way, isn't it? So this is the way. So ASC and AST2 are there and AST1 is there. So net area of steel is equal to AST1 plus AST2 and net area of compressive steel is ASC. So we can say that overall calculation of steel reinforcement has been done, isn't it? It has been done. Okay, so I'm just repeating the procedure that how this design formulas have been developed. In the first phase, we calculate the moment, you can say moment of resistance capacity of the given dimension of the beam. So based on that, you are going to calculate the maximum moment of resistance, and you need to check what factor bending moment you need to balance or you design to be done. So out of that factor bending moment, if this value is greater than mu lim, okay, then you need doubly reinforced section. Otherwise, you can go for singly reinforced section only. If factor bending moment is greater than mu lim, then one portion would be designed as per mu lim, and another portion will be designed, means ASC and AST2 will be designed as per the axis portion. So what is axis portion? It is factor bending moment minus mu lim. So mu lim से आपने AST1 निकाल दिया. AST1 is also known as the balanced steel for that particular size. Okay, and AST2 or ASC you have calculated from the axis portion. Axis portion steel calculation has been done by this technology, this method. Okay, so ASC and AST2. Yes, sometimes here you can be in trouble that how to get the value of FSC. Let me tell you one simple thing. If nothing is given to you, then try to take FSC as 0.87 F5, especially in gate. Otherwise, we do have some thumb rule and all. Based on the strain value, you can calculate, interpolate the value of FSC. Generally, in engineering services conventional question, some hint would be given for FSC. Sometimes they give you tables, stress strain tables. Sometimes they give you the value of FSC based on the cover ratio, cover to effective depth ratio, and sometimes they are going to given you it is this percentage of the design value and all. Okay, so they will be giving you some information. Because why I am saying that in gate, if it is not given, take 0.87 M5, because if it is not, because there is one value of strain, if that value of strain is going to be greater than that, then FSC is also fully developed, it is equal to 0.87 F5. So if no information has been given, so it's by default that FSC value is going to be in that zone only. Okay, it is going to lie in that zone only. Okay. So this is the development of design formula. Whatever I have shown you. So now see the first phase, this and this. Second phase, this. And here equate mu lim. Here equate mu lim. With 0.87 Fi into AST into D minus or simply write JD. And here it is mu lim, it is the axis bending moment, and this axis bending moment you can understand it like this, D minus DC, or you can also write it like this. Okay, so from this you can calculate the value of AST2, ASC and AST1. So like this you are going to calculate. Okay, so this is the design steps. So given value is BED, grade of concrete is given to you, grade of steel is given to you, bending moment is given to you, or factor bending moment is given to you. Okay, you have to find the area of steel. So the very first step is to calculate mu lim for singly given size. If it is less than mu1, then as I told you earlier, no need of doubly section. But yes, if effective bending moment is greater than mu lim, then we have to calculate AST1, AST2 as well as ASC as discussed in the earlier steps. Okay, so this is the case. So now we can do a numerical here. Now we can do a numerical here. The size of the beam is restricted to 250 by 500 mm overall. It carries a superimposed load of 25 kN per meter over the span of 6 meter. Okay, excluding self weight. Determine the reinforcement by limited state method. We have to use M20 concrete and Fe415 steel, and effective cover we can take as 40 mm. And here the stress strain value relation has been given to you, so you need to interpolate the exact value of strain. Based on that you have to calculate the value of FSC. Okay, so like this we have to do, like this we have to do. Are you getting this point? Okay, so anybody? ठीक है, चलो इसको करते हैं डियर सॉल्व. इसको सॉल्व करते हैं. लेट मी यूज माय कीबोर्ड. आप भी ट्राई कीजिए. ओके, सो स्टेप नंबर 1, calculate axial limb, and we know axial limb is nothing but what is the grade of steel? 415. So for 415 it is 0.480, although I can write the exact formula for you guys. If we are going to substitute here 415, so it is coming out to be how much? 0.48 D. It is 0.48 D. Okay. Now, so what is the value of D? D is 460 because it is 500 overall depth and 40 mm is the cover. Okay. So like this. So if this is the reinforcement value, okay, so this is how much? 250. This is 250. This is how much? 460. This is 0.48 D. So this is 460. Why? Because overall it is 500 and this cover is 40. So this is axial limb. What is about axial limb? Axial limb is coming out to be how much? So axial limb is coming out to be, anybody? देखना जरा कितना आ रहा है. कैलकुलेटर निकालना पड़ेगा. I have final answer, but intermediate steps I do not have. So 0.48 into 460, so it is 220.8. So axial limb is 220.8. Okay. So reinforcement निकालनी है. So we will be going for balanced condition only, limiting condition only. So this value is 220.8. Okay. So what next? ठीक है. अच्छा, तो दिस इज AST1 और ये आपका AST2 वाला पोर्शन हो गया. ओके, सो लेट मी कॉल इट AST1 ओनली. So what about maximum limiting value of moment here? What is M1? So उससे पहले आपको निकालना पड़ेगा कि कितना बेंडिंग मोमेंट यू हैव टू डिजाइन हियर. तो कितना बेंडिंग मोमेंट आपको डिजाइन करना है, उसके लिए व्हाट कंडीशंस हैव बीन गिवन टू यू. दिस इज द लोड 25 kilonewton meter. Okay, and simply supported condition is there and span is 6 meter. So we also have to include the dead load. What about dead load? So dead load or self weight is equal to density of concrete. You guys can take 25 unit weight of concrete. Cross section is 0.25 into 0.5. अब भाई यहाँ तो आप ओवरऑल रख के लोगे, वजन तो पूरा लगाएगा भले ही इफेक्टिव है या नहीं है. सो दिस इज हाउ मच? 3.125. Now overall is what? 25 and 3.125. So overall is total load 28.125. But as I told you, in a limit state we have to work in terms of factored load. So what is W? W is 28.125 and partial factor of safety for dead load and live load is 1.5. So it is coming out to be 42.1875 kilonewton meter. Now what is the moment of maximum bending moment, or you can say factored bending moment? What is the factored bending moment? Factored bending moment. So this is W L square by 8. So it is W into L square by 8. So it is coming out 189.84 for kilonewton meter. So this is the maximum amount of factored bending moment which is coming. Okay, तो factored bending moment आ गया मेरे पास इतना. ठीक है, और उसके बाद dear we can check the MU limb value. MU limb value is how much? MU limb value also you can calculate from here. So MU limb value is अगर आप देखोगे यहाँ पे it is 0.36 FCK B into axial limb into D minus 0.42 axial limb. Okay, so ये आ जाएगा मेरे पास 0.36 into ग्रेड कितना दे रखा है? ग्रेड दे रखा है मेरे को 20. B is 250 into 220.8 . So this is 145.97 किलो न्यूटन मीटर। मैंने 10 की पावर 6 से भी डिवाइड कर दिया। तो इसका डिपार्टमेंट यहाँ चलेगा और जो बचा हुआ है कितना था, 189.44 था ना, नहीं 0.844, और ये देखेगा किसको, दिस इज गोइंग टू सी 43.88, ये ठीक है। सो 145.97 के लिए AST1 डिजाइन करेंगे, एंड फॉर दिस फॉर रिमेनिंग 43.88 वी हैव टू डिजाइन AST2 एज वेल एज ASC। ओके, so this is the factored bending moment जो हमने निकाला। Now what about AST1? AST1 calculation is not tough, it is simply mu lim or m1 over 0.87 fy into d minus 0.42 of axial lim. So if you are going to do this, then AST1 you will be getting, it is mu lim डाल दोगे 145.97 इंटू 10 की पावर 6 कर दो 0.87 415 इंटू 460 माइनस 0.42 टाइम्स ऑफ कितना हो जाएगा 220.8। तो जरा देखो कितना आ रहा है, it is 1100.82 mm square, but is not the entire area of tensile reinforcement. It is that portion of tensile reinforcement which would be needing for mu lim, but for excess amount of bending moment we have to look for area of steel 2 as well as the area of steel in compression. So now AST2 is how much? AST2 is how much? It is excess bending moment. What is excess bending moment? 43.88 divided by 0.87 Fy, okay, into D minus DC. So what about this? It is equal to 43.88 43.88 So this is 289.36 mm square. 289.36 mm square. Now my dear friend, we need to calculate ASC. ASC निकालना है, और ASC के लिए आपको पता है कि मुझे जरूरत पड़ेगा FSC का. So ASC is also M2. It is FSC minus 0.45 FCK into D minus D dash. अभी FSC निकालना थोड़ा सा एक्स्ट्रा पड़ जाता है यहाँ पे, क्यों? क्योंकि एक्चुअली दिस इज गिवन टू यू, दिस इज गिवन टू यू. अगर मैं यहाँ पे इसको आपको बताऊं, दिस इज अ केस, ओके, दिस इज अ केस, this is a case. So अगर मैं यहाँ पे एक strain diagram बनाऊं, then this strain diagram will look like this. it will look like this. Okay, this will look like this. So this value is 0.0035. 0.0035. So first of all, you have to calculate the value of strain at the level of compressive steel. Means at this level you need to calculate. So can anybody tell me what is this strain value? What is this strain value here? So this strain value, this axial lumino is what? It is 220.8. It is 220.8. What about this? This is 40 from top. So can't you use similar triangle and find the value of strain? It is 0.0035 upon 220.8 is equal to epsilon divided by 220 minus 40, 180.8. From this strain value at the level of compressive steel can be calculated, and this is coming out to be 0.0035 into 180.8 divided by 220.8. So this strain is coming out to be 0.00286. So this 0.00286 is lying here. Where? 286. ये इन दोनों के बीच में लाई करना. So your strain value is going to be lie somewhere here. So if you are doing the interpolation, अगर आप interpolation करो डियर, तो आप क्या लिख सकते हो? जैसे अगर आपको interpolation करना है, so you can write that what is the value of FSC? You know it is the strain value and it is FSC value. So interpolation you all can perform. What is interpolation? So it is 352 plus 361 minus 352 over a strain difference of 0.00380 minus 0.00276 into actual difference 0.00286 minus 0.00276. So if you are going doing this, then this strain value is sorry, stress value is coming out to be कितना आ जाएगा ये आपको इंटरपोलेट करके कितना आ जाएगा? Let me calculate this. $352.952. It is 352.952. 352.952. देख भी सकते हो, इसके पास ही रहने वाला था, कोई बहुत ज़्यादा अंतर नहीं आएगा. So now use this 352.952 and get ASC. So on substituting this value here, so your ASC is coming out to be 304.2 mm square. So you can say that your total area of steel, ASC is 304.2. Now area of steel is AST1 plus AST2, तो ये जगह 290 के आसपास हो गया, ये 1100 हो गया, तो ये 1390 ही हो गया. It is 1390 mm square and it is also mm square. ठीक है. So this is the way to calculate area of compressive reinforcement and tensile reinforcement. Okay. So this was the design problem here. ये design problem था आपका. I hope I have explained you all the steps very clearly. So based on this, I have two assignments for you. Ditto same है, data के साथ थोड़ी सी tampering की है, and you can see length 6 की जगह 5 कर दिया, सुपरइम्पोज लोड 25 की जगह 24 कर दिया, तो आप इससे और कवर जो है आपका 50 कर दिया इंस्टेड ऑफ 40 mm. So solve this assignment number 1 for you, and this is the second assignment. It is also a good question, ESC prelims, ESC means question. So try to perform these two exercises and we will be discussing. So like I told you, here FSC value is directly given to you, 0.9566 times of yield value. FYD is what? I hope you all know. It is 0.87 yield design, FY. Okay, FYD is nothing, 0.87 of FY. Okay, so read the question very carefully and perform the exercise. So you will be getting your answers there. Are you getting the point? ठीक है, तो ये करना है आप लोगों ने. ओके, सो चलो ठीक है, यहीं तक रहने देते हैं. लेट्स कीप द सेशन ओनली अप टू हियर एंड डू नॉट फॉरगेट टू एनरोल योरसेल्फ इन AIMT ऑल इंडिया मॉक टेस्ट फॉर गेट 2022 डियर. अगला AIMT होगा आपका 9 जैन को. ये होगा आपका 9 जैन को. एनरोल नाउ डियर फॉर दिस, एनरोल नाउ. लाइव मेंटरिंग प्रोडक्ट इज, आज अपना सब्सक्रिप्शन प्लान कर रहे हो तो आप AISH 10 लगा करके instead of 10% you can avail 22%, but this offer is only valid for today midnight, till today midnight. So thanks a lot dear. So let's have a small video on AIMT all India mock test, and after that we will be meeting again at 4:15 dear. Okay, bye.